The slope or the gradient of linear functions. How do we find it? There's different ways of finding it, of course. Rise over run, probably the first way we saw it. Here's a line. In case you need me to tell you, that's a line. There's a 0.55 and another 0.21. Rise over run, we could create a triangle and work it out, but of course we turned it into a formula to make life easier for ourselves. Now this one, it does matter that they're in the same order, because it would make a difference if you were to swap them round. So whichever one I pick for y2, then the corresponding x value has to be x2 for this formula to work. And we would get, for our example there, what do we end up with? 4 over 3. So it's got a slope of 4/3. So that's one way, that's a second way. There is a third way, which often people forget about. Here's another line. If you know the angle of inclination of the line, and when you're talking about angle of inclination, it's always measured to the positive x-axis, 120 degrees. Then the slope of that line will always be the tan of that angle. When you think about it, rise over run, opposite over adjacent, hence why it's the tan ratio. So for our line there, if that's 120 degrees, then I know it's got a slope of minus root 3. In fact, I could work out the angle for the other one, let's call it alpha. I know that tan alpha is 4 on 3. I'm not going to get an exact value for that one, but approximately 53 degrees would be the angle. Two lines are parallel if they have the same slope, and no, before anyone says it, I did not spell if incorrectly. That is spelt correctly. Okay, the IFF if. Have we seen the IFF if before? IFF if means if and only if. And what it means is it works both ways. So whilst I'm saying here, two lines are parallel if they have the same slope, you can read it backwards and say, well, if two lines have the same slope, they are parallel. So it depends what information you have. So if we know slope 1 equals slope 2, in other words. Perpendicular, again, it's the IFF, but the slopes would be the negative inverse of each other. Or another way of saying that, they multiply together to give -1. We have 4 points, A, B, C, and D. We need to find A such that those two lines are parallel. Okay, well if they're parallel, the slopes must be the same. Slope AB turns out to be 2. Slope CD turns out to be 2 over A minus 3. Well, they've got to be equal. Therefore, playing around with it, eventually we get that A is 4. If they were perpendicular, well then I know they've got to multiply together to give -1. Again, a bit of algebraic fraction work, play around with it. A is -1. Okay. We've got 3 points that are vertices of a parallelogram, and we have to find the coordinates of D, the fourth vertex of a parallelogram. Now, you can do this a long way, you can do this a quick way. Let's plot the points. There's A, B, and C. The question first of all is, where is D? The naming of the parallelogram is important. So it's been called A, B, C, D, so we must go around in that order. And if I'm going to get a parallelogram, well there's A, B, whoops, D must be down there to create a parallelogram. Okay. Question is, what are its coordinates? Now the long way of doing this would be to, okay, let's calculate the equation of the line AD, which I can do because I can work out the slope of BC. I know a 0.40, I can come up with an equation. Then I could go and do the same thing for CD. Then I could go and solve them simultaneously. Point of intersection would be D. That's the long way. The quick way is to use geometry. Right? What do we know? We know opposite sides are parallel. Well, if they're parallel, then to get from B to A must be exactly the same path as I go from C to D, because they're parallel. So to get from B to A, I go across 3 and down 5. Therefore, to get from C to D, I must go across 3 and down 5. Thus, the coordinates are 0, -10. So essentially I'm just saying the slope of those two lines are equal. But rather than solving it in an algebraic way, I'm doing it geometrically to come up with the answer. If you want to prove 3 points are collinear, so they lie on the same line, how would I do it? Well, pick any two. I've just chosen A and B. It doesn't have to be A and B. It could be A and C, B and C. Doesn't matter. Just pick two and find the slope. Then pick another pair. So I've said, okay, let's do AC. Now, if those slopes are equal, then the 3 points must be collinear. The reason? Well, if they're equal, we know they're parallel, but they have a common point. How could parallel lines have a common point? What is the only way parallel lines can have a common point? I knew that would be your answer, and you're sort of correct. But yes, that's the answer we need for the purposes of this. Got to be the same line. There is another way parallel lines meet, by the way, because all parallel lines meet out at infinity, but that's another story. 70.